Solving simple trigonometric equations 20-1. Guys, I do need to let you know, when they say solving simple trigonometric equations, simple is misleading. They want you to say, simple makes you think that it's easy. These are anything but easy. They are many, many steps where you can get lost in. It takes practice. You just can't do this one time and be done with it. You've got to do repetition. So when I give you the homework, you got to make sure you do the homework. All right, I'm going to work Try These letter A from your Springboard book, and it wants the general solution for sine x equals -1/2. Well, the first thing we need to do is we need to get x by itself. When we get x by itself, the way you do that is you take arc sine of both sides simply because you have sine. If you have tangent there, you would take arc tangent. If you had cosine there, you take arc cosine. Don't add or subtract by sine or divide by sine and think that gets rid of x. This is not sine times x. This is sine of x. There's a difference. All right, so let's take arc sine of both sides. That's going to give me x equals arc sine of -1/2. Now, we need to go ahead and use our unit circle, and we need to know which quadrants to look for arc sine. Well, the way that we do that is we do CAST, C-A-S-T. And the ST is where sine and tangent are negative, because sine and tangent in quadrant 4 is between -π/2 and 0. Tangent does not include -π/2. Well, arc sine here is -1/2. So we're going to look in quadrant 4 for a y value on your unit circle that is -1/2. Well, conveniently, that works out to be -π/6. Well, but -π/6, that's great. But unlike other math classes, once you get what x equals, we're not done here by any means. Because now we're going to have to use our reference angle to actually solve this problem. All right, so sine, arc sine, this is in quadrant 4. And to find your reference angle from the last video, we said my reference angle, which I'm going to use phi, has to be the absolute value of -π/6. Which is just going to be π/6. Well, on the last video, I showed you simply how to find the reference angle, not how you actually use your reference angle. So here's how you actually use your reference angle. If you're in quadrant 1, if you need an answer in quadrant 1, it is just your reference angle. If you are in quadrant 2, you're going to do 180 degrees minus your reference angle, or pi minus your reference angle. Just depends if you're doing degrees or radians. If you're in quadrant 3, you're going to do 180 degrees plus your reference angle, or pi plus your reference angle. It just depends on whether in degrees or radians. And last but not least is quadrant 4. With quadrant 4, you're going to do 360 degrees minus your reference angle, or 2 pi minus your reference angle. So really, when you're solving these problems, these simple trigonometric equations, you need to simply ask yourself, if you go back to the original equation right here, or whenever you get to where you can isolate x, when you have just a single trig function, you ask yourself, sine x, -1/2. Where is sine negative? Quadrant 1, 2, 3, or 4? Well, we learned a little while ago that to find out where everything's positive and negative, we can use that little memory trick. All students take calculus. Well, this tells us where everything's positive. All means sine, cosine, and tangent are all positive in quadrant 1. Sine is the only thing positive in quadrant 2. Tangent is the only thing positive in quadrant 3. And cosine is the only thing positive in quadrant 4. So for all the trig functions, there are 2 quadrants where it's positive and 2 quadrants where it's negative. If this right here tells you where everything's positive, it also tells you where everything's negative. Because if sine is positive in quadrant 1 and quadrant 2, sine must be negative in quadrants 3 and quadrant 4. Well, we're looking for an angle in quadrants 3 and 4 because our sign is negative. So we're looking for our answers, our angles down here, quadrant 3 and quadrant 4. Well, we're going to use our reference angle to actually find those. Down here, quadrant 3 and quadrant 4 simply says we have to do pi plus your reference angle and 2 pi minus your reference angle. And we found the reference angle right here at pi over 6. So let's do a little bit of math. Now keep in mind, we're going to find the general solution. So once we find these solutions, we're still another step. All right, so quadrant 3. We have to do pi plus my reference angle, which is pi over 6. Your favorite thing, adding and subtracting fractions. Put pi as pi over 1. Multiply your bottoms. That's going to give you a 6. Multiply up. 6 times pi is 6 pi. Plus, multiply up. 1 times pi is pi. That gives me an answer of, we have 6 on the bottom. 6 pi plus pi gives me 7 pi. So that gives me one of the angles in quadrant 3 is 7 pi over 6, where when you do sine of 7 pi over 6 is going to give you negative 1/2. And when you look at your unit circle, that is a true statement. Okay, quadrant 4. Quadrant 4, we have to do 2 pi minus my reference angle, which is pi over 6. Put your 2 pi as 2 pi over 1. Multiply your bottoms. 1 times 6 is nothing more than 6. Multiply from back to front. 6 times 2 pi is going to give me 12 pi. Bring your operator over minus. Multiply bottom front to back top. 1 times pi is pi. Do your math on top. My bottom is still 6. My top becomes 12 pi minus pi, which is 11 pi. So this is the angle in quadrant 4, where my sign value is going to be negative 1/2. And if you look at your unit circle, that is a true statement. Now, to actually write the general solution. The general solution is going to be is going to look like piecewise. We're going to say x, because originally they're saying what angle x over here. So we're going to use whatever they put here. X equals, we're going to take both of our answers, 7 pi over 6 and 11 pi over 6. But that's only one answer. Unfortunately, with sine and cosine and tangent, there's actually an infinite amount of answers. The general solution is asking for the infinite amount of answers. So we're simply going to do the coterminal angles, 2 pi k, such that k is an element of the integers. And we do the same thing on the bottom. 2 pi k such that k is an element of the integers. This right here is the answer to sine x equals negative 1/2, the general solution answer.